Alright guys, Mr. O'Shea here. Today we're going to do functions and relations. Now a relation is any ordered pair. Typically we see these as x's and y's. We call those a relation. We can also consider them inputs and outputs. And we see these all the time. An ordered pair is a relation. So if you took an x and a y value, those are all relations. So we can focus on just one, -2, -2. And we can translate that into a table where we have -2, -2. We can translate it into a graph. We can even translate these into mapping diagrams where your input is your x and your output is y. And we see an input is -2, the output is 2. We see these all the time. Now we're going to talk about domains. And a domain is all of the input values. Or in other words, we're talking about all of your x values. And we also have range, and range is all of the output values. And the output values are going to be all of your y values. So if I ask you guys to identify the domain and the range of a function, the domain, all we do is list off all of your x values. We've got 3, -1, 2, -2, and 0. So we're just going to list those off. 3, -1, 2, -2, and 0. And then if I ask you for the range, you're going to list off all your y values. Every single one of the y values. Every unique y value. If one repeats itself, we don't have to list it twice, and we'll see that later on. So 2, 0, -1, 1, and 3. Now, as we said, relations don't just come in the XY form, it also comes in graphs. So if I asked you for the domain of the graph, we'd list off all of the x values that graph hits. So it goes from -2 to 2. And notice that on this specific case, we actually go ahead and use a different set of brackets. We use the brackets because we don't want to list off every number in between -2 and 2 because the graph hits them all. We could just use the brackets and say it goes from -2 to 2, which is different than what we did in the top example because we used the kind of fancier brackets to identify that it doesn't hit every single number, it just hits very specific numbers, just so we know. Kind of the same idea that we had with interval notation when we did inequalities. Alright, so if we're looking for the range, we're going to be looking for all your y values. How high and low does the graph get? We always give the lowest value first, which is -3, followed by the highest value, which is 4. Number 2, same deal. The domain, well, these arrows on the end mean that that graph extends forever and ever and ever. And that goes forever and ever. So it doesn't really have a left bound or a right bound. So we're going to say it goes from -infinity all the way to infinity. And your range, the smallest value it gets and the highest value, well, we don't really know the highest value because it keeps going up. But we do know the smallest value. It stops at 4. So your bottom is 4, -4, and your top would be infinity. 3, same deal. These arrows extend forever, so it goes forever left and forever right, which means the domain is -infinity to infinity. And the range, we start with the lowest number, it goes down forever, so that would be -infinity. And the highest that graph ever gets is 4. So -infinity to 4. Number 4, domain. It's got a slight kind of bend to it, so that one goes forever. It will take a long time to get to -infinity, but it will get there. And the right goes forever. It's also infinity. The range, the bottom value, well, that goes down to -infinity. And the top value, the highest that graph ever gets, it's right up there. It's kind of in between 4 and 5, so we'll go inside and say 4.5. All right, a function. A function is a very specific type of relation. It's one in which each x value or each input has exactly one output. Now it has to be a unique output. These graphs, you can kind of think of them they have to be predictable. So if we took an example down here, and I always kind of go with an example of like a vending machine. Now, I know it's kind of a weird example, but if this over on the left-hand side was a vending machine and you press the smiley face, you think that you would get the frowning face out. It's predictable. You know what you're getting. If you press the button number 5, you're going to get the frowning face. If you pressed A, you're going to get B. This one is that vending machine that every time you press the button, you know exactly what you're getting. It is predictable. Each input has an exact one output, so this is a function. Now in the second one, think the vending machine example again. If you press smiley face, you get frown. If you press 5, you get frown. But then you press 5 again and you get a 4. Now that's an issue. We want it to be predictable. If I pressed 5, one time I got frowning face, one time I got a number 4. Well, that's not necessarily, we don't know what's coming out of it. Each input has one output. I've got an input and then I've got 2 outputs, so that's a problem. We'll keep going though. If I press A, I get B. That's the issue right there. That tells me it's not a function. I've got one input and it goes to 2 different outputs, so it's not a function. All right, so I want to state the domain and the range and then tell me if it's a function or not. Domain, list off your x values, -3, -7, -4, -9. And the range is going to be 1, 9, 6, and 11. Now each x value goes to one specific y value, so this one is a function. Number 2, domain, is going to be -2, 2, 1, and we don't need to relist the number 2 because we've already got it in there. Range is going to be -2, 2, 0, and 3. In this case, we see that 2 goes to 2, but then all of a sudden 2 goes to 3. That's a problem. This one is not a function. It's not predictable. Number 3, we've got domain is -5, -4, -3, and -4 again, so we don't list it. Range is going to be 1, 2, and 3. We don't need that other 3. Now, a lot of people are quick to say that this is a function because it's got 3 domains, 3 ranges, but it's not. -4 goes to 2, and -4 goes to 3, so it's not a function. I'm just going to abbreviate NF for now. Domain is 10, 9, and 8. We don't need that other 8. Range is 1, 2, 3, and 4. This one is clearly not a function because 8 goes to 3 and 8 goes to 4, so it's not a function. However, if 8 went to 3 and then that other 8 also went to a 3, you can have duplicate sets. That would mean it was a function, but in this case it didn't, so it's still not a function. All right, domain is A, C, E, G, and I. Range is going to be B, D, F, H, and I. This one, each letter goes to a specific letter, so it's a function. We've got domain is A, they're all A's, so just A. And the range is B, C, D, and E. Clearly, A goes to way too many different things. It's not a function. Number 7, domain, we've got A, B, C, and D. The range, we just have B, it looks like. This is fine. This is one of those examples where, like, if you ever seen if we kind of use that vending machine example again, if you ever saw a vending machine where it just serves water, no matter what button you press, A, B, C, or D, you're going to get water. So this is perfectly fine. Each input goes to one specific output. You don't have a repeat input, so it's a function. Number 8, we got the mapping diagram, your inputs and outputs. Your domain is going to be all of your x values, your input values. -2, -1, 3, and 6. And your range is going to be -1, 0, and 4, all of your output, your y values. Each input only goes to one specific thing, so this is a function. All right, we've got a vertical line test. We talked about the fact that, let's stop writing for a second. We talked about the fact that XY tables could be relations and functions. Well, graphs can also be relations and functions, because that's just plotting a whole bunch of XY points. Now, rather than really kind of analyzing it too much, we've got this quick and easy test. It's called the vertical line test. And it's if you can pass a vertical line, so a line that goes up and down, a vertical line through a graph. I should have given you guys more space here, sorry. Through a graph, and it only touches the graph at one point. Then it's a function. So I want you guys to draw these two graphs on here, and I'll stop for a second so you guys can get that definition of vertical line test down. We're going to go ahead and draw two graphs on here. The first one, let's make it look kind of like a backwards S. And the second graph, we'll do the similar style thing, but it's going to kind of look like a big N. All right, I'm going to make a vertical line here. I'm going to start passing it through the graph. So as I move it, I can see that it's hitting once, it's hitting once, it's still hitting once, and then all of a sudden it hits 3 different times. It hits right here, and right here. Because it hits more than once, it's not a function. Now if we pass that vertical line through the other graph, we see it hits once, it's still hitting once, it's still only hitting in that one spot. And as we continue through the graph, it still only hits it one time. So that specific one is a function. All right, so is the relation represented a graph of a function? We're going to do the vertical line test. We'll pass it through. We see it hits 1 point, 1 point, 1 point, and 3 points. So it's clearly not a function. It's too many points at one time. Check it for number 2. 1 point, 1 point, 1 point, 1 point, 1 point. This one is a function. It only hits 1 point. Now, you guys probably aren't going to draw a line on your paper. If you just take your pencil and run it through the graph, it'd be the same effect, or your finger or something like that. I've got one last thing here, guys. It's called function notation, and we read it f of x. It's written like that, f parentheses x. It's f of x. It is not, absolutely not f times x. Okay, we're not multiplying anything here. F of x is a fancy way to write y. It's just function notation of y. So in your first one, f of x equals all that. It's really like y equals that. So we're just going to plug x in for every x you see. So it would be like me saying, hey, what does this equal if y equals x squared plus 4 when x is 8? So we write f of 8 equals 8 squared plus 4. Go ahead and solve it through. F of 8 equals 64 plus 4. So f of 8 equals 68. Second problem here. G of negative 2, if g of x equals all that. So we're going to plug in negative 2 anywhere you see x. So it's going to be g of negative 2 equals negative 4 minus 2 times negative 2. It's going to be g of negative 2 equals negative 4. That's going to give us plus 4. We multiply negative times negative. So g of negative 2 equals 0. Number 3, f of x equals negative x squared plus 5x minus 3. So we plug in plug in positive 2 for everything. F of 2. Plug 2 in for all your x's. Now I got to do my exponent first. 2 squared is 4, so I leave the negative out in front. plus 5 times 2 is 10 minus 3. That's going to give us negative 4 plus 10, which is 6 minus 3. So f of 2 equals 6 minus 3 is 3. F of 2 equals 3. All right, I'm going to leave these last two on the video playing, guys. Have a great day, and I will see you all on Monday.